Hello students, Pythagorean is here to introduce you to my most famous theorem. Be sure to take good notes and bring them to class.
Haha, I hope you enjoyed that. Anyway, let's start talking about what this thing is. A couple definitions we need to talk about before we even begin here. So first, all of this is going to be revolving around right triangles. All right, so here's a right triangle here. And this thing is what we call the hypotenuse. This is sort of the interesting, or not most important, but the new term here that we're going to need to use. So make sure you write this word down. The next slide is going to sort of show you a little bit more about what this looks like. Definitely draw some pictures, okay? So here we have a right triangle. The hypotenuse is the side opposite the right angle, okay? So it's the one that's directly across from the right angle. The other thing to notice is that it is always the longest side. So let's take a look at this. Okay, here we have right triangle. Okay, I have a leg here, and I have another leg here. Okay, you can see it kind of makes an L. And then the hypotenuse, which is the one across from it, it's always going to be the longest side. And this is what the Pythagorean theorem actually states. Okay, it says for any right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Okay, so this is going to, that sounds really confusing. So what we're going to do here is we're going to, I'm going to draw a few pictures here so you get a clear understanding of that. So this is sort of the classic example of this. Here is a right triangle, okay? And what we're going to do here is I'm going to show you that sort of what this means, okay? If I have a side length of, this is 3 units long, okay? And I've got another one is, let me do this in black here. This is 3 units long, okay? And then this one is 4 units long. Then what I'm going to do is I'm going to use the Pythagorean theorem to prove that this one is 5 units long. Okay, so let's see what this looks like. The idea is that you take the sum of the squares made by the legs is equal to the square made by the sum of the sides of the squares is equal to the square made by the hypotenuse. Okay, so here's a square that is 3 units by 3 units. Okay. And here is another square that is 4 units by 4 units. Okay. Okay, so the idea of the Pythagorean theorem says that if I take a 5 by 5 square like this, okay, I gotta make it a little bit bigger here. Okay, a 5 by 5 square, that if I take this, okay, 1, 2, 3, 4, 5, that this will, the side of this will be equal to this length here. Okay, now let's see. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 1, 2, 3, 4. This will be 16. Well, 9 plus 16 is 25. And this is a 25 square. So let's take this thing and let's kind of rotate it here and see if it actually is going to fit. And it's not perfect here, but you'll notice it does fit. Okay. Hopefully that's a moment where you went, whoa, that's kind of crazy. Yes, it is kind of crazy. Okay, so how do we use this? We're going to use this to solve missing sides of a triangle, okay? Now, the way we do this is we say that the legs on a right triangle are going to be called A and B, okay? So we're going to have A and B. A and B are the legs. So A and B. And it doesn't really matter which leg you choose, which for A and which one is B. It just matters that those are the legs, okay? They're not opposite the right 90-degree angle. C is the one that's always going to be opposite the 90-degree angle. That one is called the hypotenuse, okay? So we know that the square made by side A and the square made by side B, when I add them together, will make a square of side C. Okay? So that's what I want you to understand. It's not, this is just the formula to solve it, okay? What the Pythagorean theorem really says is if you have a square created by the side, right? If I take a square, side length 8 meters, and a side square length 6 meters, okay, and I add them together, it will equal the area, right, of this square, and I can use that to find the side length. So here, let's plug it in. I got 8 squared plus 6 squared is equal to c squared. So that's going to be 64 plus 36 is equal to c squared. 100 is equal to c squared. Well, the area of 100, okay, I have a square with the area of 100. If I take the square root of that and I take the square root of this, I'm going to get that this hypotenuse is equal to 10. Okay, and in this case, it's going to be equal to 10 meters. Okay, let's try another one. Why don't you try this one? Go ahead, pause the video, and you try it. Okay, hopefully I had a chance to do that, and we'll go ahead and we'll do this one again. Okay, and we have a squared plus b squared is equal to c squared. Okay, so a squared is going to be 5, so I've got 5 squared plus 12 squared is equal to c squared. Okay, and it doesn't matter if you did 12 squared or 5 squared, it really doesn't matter. So then we're going to square them. 25 plus 144 is equal to c squared. I'm going to add them together. I get 169 is equal to c squared. Take the square root of that, take the square root of this. I get 13 is equal to c. Now notice, I don't have to worry that plus or minus here because I can't have a negative length of a hypotenuse. Okay, it just wouldn't make sense. And this is what I was saying before. Make sure that you understand if you come up with a plus or minus solution that the negative one actually does make sense, and here it doesn't. So 13 meters is the length of the side of my hypotenuse. Okay, and what this is saying is that 169, that would be the square, right? If I drew a square out here, right, with the side length of c, okay, the inside of this would be 169 square meters, and that c has to be 13 meters then. Okay, so let's try another one. Now this is one where I have the hypotenuse, but I don't know one of the sides of the legs. Again, a squared plus b squared is equal to c squared. So I'm going to plug it in, right? This tells me that b is there, so I know that a is 10 squared plus b squared. Don't know it. C squared is 12 squared. So that's 100 plus b squared is going to be b squared. Well, this is going to be 144. Now, I want to find out what b squared is, so I'm going to subtract 100 from both sides. And I get b squared is equal to 44. Okay, take the square root of both sides. Okay, and I've got that b is equal to, grab a calculator real quick here, and I've got, actually here, we'll do this. We'll use this calculator, and I'll do 44 and square root of that. So then I've got 6.63. I'll just round it to the hundredth, so 6.63 meters. Okay, and that makes sense because when I check this, remember the hypotenuse has to be the longest side. So if I came up with a leg that was longer than a hypotenuse, then I knew I would have done something wrong. But this would make sense that b is 6.63. Now this, obviously, this is not to scale. Scale meaning like this, if this was really 10 meters and this, or if this was really 12 meters, then this would have to be longer. But which is just for practice right now. Okay, you try. Go. Okay, hopefully you did a squared plus b squared is equal to c squared. Okay, in this case, I know a, so it's 7 squared plus b squared is equal to 25 squared. So 49 plus b squared is equal to 625. Okay, I'm going to subtract 49 from both sides, subtract 49 from here, and I get b squared is equal to 625 minus 49, 576. Okay, I'm going to take the square root of that, take the square root of that, and I'm going to find out that b is equal to, I think that's 24 meters. Let's just check. Calculator, 576. Or square root button. Square root. 24. Okay. There you have it. So I know it's 24 meters. Okay. Now, this is sort of the converse of what we're talking about. If I know that if I have 3 sides of a triangle and I want to find out if it's a right triangle, I can apply the Pythagorean theorem to see if it works. So if I do 15 squared plus 8 squared, whoops, actually I have all this in here already. So if I do 8 squared plus 15 squared is equal to 17 squared. I'm going to check to see, does this actually work, okay? So what I'm saying here is this a solution? So look, let's take a look. 64 plus 225, does that equal 289? I'm not sure. It does. 289 does equal 289. So it is a right triangle. Okay? You go ahead and you try this one. Okay, Hopefully when you went through there you said, is this a right triangle? So we're going to plug in the sides. Again, the squares, I have to do 3 squared plus 5 squared. If it equals 7 squared, then it's a right triangle. If it doesn't work, like this one, right, because 9 plus 25, 34, if it doesn't work, that means that this, right, this angle here is not a 90-degree angle, so this is not a right triangle. Okay, so you can use the Pythagorean theorem to prove whether or not something is a right triangle or not. You can, okay, or you can use it to find a missing side if you know that it is a right triangle. Okay. Okay. So that's really the basics of this. I tried to keep this short. I know I went real fast. You'll have plenty of time. We'll have some time in class on Monday to talk more about it. Couple of common mistakes that you'll see in popular culture. And I want you to take a look. We'll take a look at these. I think these are just kind of fun here. So bear with me a second, and I'll get it all set up. So this is from The Wizard of Oz, and I think you'll know what the second one is.
I hereby confer upon you the honorary degree of Ph.D. Ph.D.? That's Doctor of Thinkology. Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, George! I've got a break!
The sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
That's a right triangle, you idiot! Don't!
So hopefully you have a better understanding of it, and if you don't understand those, come on into class and we'll talk more about it. All right, have a good weekend.